Chemical reactions result in the loss, gain, or rearrangement of valence electrons. So only the valence electrons are involved in bonding. Make sure that you can remember how to get the valence electrons from the periodic table. Everything in this column has one valence electron. These all have two valence electrons. We have 3, 4, 5, 6, 7, and 8 valence electrons, with the exception of helium, which only has 2. But everything else that's a noble gas has 8. We're going to be focusing on drawing Lewis structures for covalent compounds. Covalent compounds involves the sharing of valence electrons between atoms. On your paper, you have the example phosphorus trichloride. So the first thing we need to do is write the formula for that. So phosphorus is P. There's no prefix, so there's only one P. And then trichloride is 3 chlorines. Next, we're going to add up the total number of valence electrons that PCl3 has. So looking on the periodic table, I see that P has 5 valence electrons, and each chlorine has 7, but there's 3 chlorines. So 5 plus 21 gives me 26 valence electrons to work with. Next, I need to determine who my central atom will be. This is the atom with the fewest number or the least electronegative. In this case, I only have one P, so that'll go in the middle. An exception to that is hydrogen. Hydrogen will never go in the middle. Next, you're going to place all the other atoms around the central atom with lines to represent a covalent bond. We'll subtract 2 electrons from the total number of valence electrons for every line or bond that we draw. So on your paper, go ahead and put P in the middle and your 3 chlorines coming off of that P. We had 26 valence electrons, but again, we've used 6 electrons, so we have 20 left. So you don't need to draw the dots, but if it helps, you can draw it like that, so you can see that each line represents 2 electrons. Now we need to fill the octets. Octets being 8 electrons. Everything needs to have 8 electrons when you're done, with the exception of hydrogen. Hydrogen will only get 2 electrons. Hydrogen will not get dots. Hydrogen will not get a double bond. So looking at this molecule, right now this chlorine only has 2 electrons. So that means it needs 6 more. This chlorine only has 2 electrons, so it needs 6 more. This chlorine only has 2 electrons, so it needs 6 more. And then don't forget about the central atom. The central atom currently has 2, 4, 6 because each line counts as 2 electrons for each of them. So that means the center atom needs 2 more. I have 20. I need 20. Because 6 plus 6 plus 6 plus 2 is 20. My need and have are equal to each other. So at this point, I'm going to add dots to fill in those octets. So that chlorine gets 6. That chlorine gets 6. That chlorine gets 6, and this phosphorus gets 2. Before moving on, always double check, does everything have 8? So 2, 4, 6, 8. Notice that chlorine has 8. 2, 4, 6, 8. That chlorine has 8. 2, 4, 6, 8. That chlorine has 8. And the one in the middle has 2, 4, 6, 8. So it also has 8. So everything has 8. And then the other thing you need to check, did you use 26 electrons No more, no less. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this must be the correct structure for PCl3. If our central atom if everything doesn't have at least 8, that's when we're going to have to double and triple bond. So carbon monoxide, we have 1 carbon and 1 oxygen. So our formula is CO. Carbon has 4 valence electrons. Be careful not to use the total number. We want to be using the valence electrons. And then oxygen has 6. So that gives us 10 altogether to work with. So we're going to connect our C and O with a bond and subtract 2. So we have 8 left. This carbon needs 6, and this oxygen needs 6. Again, this is how many I need. So I need 12. I have 8. And again, I'm getting that it needs 6 more because they each have 2 because they're sharing those 2, and they're all trying to get to 8. So 2 plus 6 is 8. So in this case, I need more than I have. So when you need more than you have, you need to subtract those numbers. So I'm 4 short. Divide how much you're short by 2 because that's how many more lines you're going to need. So 12 minus 8 was 4. 4 divided by 2 is 2 more lines. Well, there's only one place I can put my lines in this problem, so I'm going to put them in the middle. And then I'm going to fill in my dots. So right now, they each have 2, 4, 6. So that means that I need 2 dots on each of them. Again, before moving on, double check, did everything have 8? 2, 4, 6, 8, yes. And 2, 4, 6, 8, yes. And did I use my 10? No more, no less. 2, 4, 6, 8, 10, yes. So that's why that's the correct structure. I've used all of my electrons and everything has 8. Again, it doesn't matter that carbon only came in with 4 or oxygen only came in with 6. Everything must get 8 before moving on. So go ahead and pause the video and try doing this one on your own. Restart when you are done. So silicon dioxide was your formula. You had 4 valence electrons for silicon and 6 for oxygen times 2. And again, we're adding those up. So you had 16 to work with. So silicon goes in the middle. You should subtract 4 because you've used 2 lines. Each line counts as 2 electrons. And then this oxygen still needs 6 because again it has 2. 2 minus 8 needs 6. Silicon has 2, 4, so silicon still needs 4 electrons. And that oxygen still needs 6 because it has 2 electrons with that lone, bonding pair of electrons. So 6 plus 6 plus 4 is 16. So I need 16 and I have 12. 16 minus 12 is 4 divided by 2 means I need 2 more lines. In this case, I have 2 places I can put those lines, so I'm going to make it symmetrical and put 1 line on each of them. So now my oxygens have 4 electrons, and so since they have 4, they need 4 more. My silicon has 2, 4, 6, 8. So silicon is now good. So I double check, does everything have 8? 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Everything has 8. And did I use 16? 2, 4, 6, 8, 10, 12, 14, 16. Yes, so this is my final structure. Before moving on, let's talk about some vocab. This is a lone pair of electrons. Every line that we draw is a bonding pair of electrons. And in this case, we have 2 lines, so this is what we refer to as a double bond. The most you can have is a triple bond. Okay, go ahead and pause the video and try this one. Restart when you get stuck or when you're done. So we have 1 sulfur and 2 hydrogens. So hydride is hydrogen. Sulfur is 6 valence and each hydrogen is 1. So we have 8 valence electrons to work with. Sulfur should go in the middle. We need to subtract 4 electrons because we drew 2 lines. My hydrogen is good with just a line. So again, no dots or double bonds on hydrogen. Hydrogen is good with just the line. So the only element we care about in this case is sulfur. Sulfur currently has 4, so it needs 4 more. So I need 4. I have 4. Those match. So I'm just going to add dots on my sulfur or lone pairs. So this is my final structure for sulfur dihydride. Again, no dots on hydrogen. Make sure that you've written this on your paper somewhere. Go ahead and pause the video and try this one on your own. Restart when you're done or if you get stuck. So carbon tetrahydride would be 1 carbon and 4 hydrogens. Carbon has 4 valence, each hydrogen has 1. So we have 8 electrons to work with. Carbon goes in the middle. We've drawn 4 bonds, so that's 8 electrons that we need to subtract. So we don't have any left. All of our hydrogens are good because they're good with just 2 electrons. And our carbon wants 8, but our carbon currently has 2, 4, 6, 8. So carbon's good. So this was our structure. So we didn't have to add any lone pairs in this problem. Go ahead and pause the video and try this one on your own. Restart when you're done. So water is just H2O. And so we have 1 valence for hydrogen times 2 plus 6 for oxygen is 8 valence electrons. You should have put oxygen in the middle and subtracted 4, so we have 4 left. Our hydrogens don't need any, but our oxygen needs 4 more. We need 4, we have 4, so we can just add them as lone pairs. And that's our final structure. Everything has 8, besides hydrogen. Hydrogen has 2, and we've used 8 electrons. Go ahead and pause the video and try this one on your own. Restart when you're done. So carbon tetraiodide is 1 carbon, 4 iodine. Each carbon has 4 valence, and our iodine are 7. So 7 times 4 is 28, plus 4 is 32. Carbon should have went in the middle. So we've drawn 4 lines, so you should have subtracted 8, giving you 24 left. Notice carbon already has 8 electrons, 2, 4, 6, 8, so carbon's good. Each iodine only has 2 though, so each iodine still needs 6. 6 times 4 is 24, so you can just add those 6 as lone pairs. Notice when I'm putting my lone pairs, I'm making it like a box where 2 go on each side. I'm not putting any right here where the line is. So make sure that they are on the outside and that they're in pairs. So that's my final structure for carbon tetraiodide. Go ahead and pause the video and try this one on your own. Restart when you're done. So arsenic had 5 valence, and each Br is 7. So 7 times 3 is 21, plus 5 is 26. As should have went in the middle. We drew 3 lines, so that's 6 electrons that need to be subtracted. Each Br still needs 6 because they currently only have 2. So each Br needs 6. And then As currently has 2, 4, 6. So As still needs 2. So that means I need 20 electrons. I have 20 electrons. Those match. So I can add them as lone pairs. So that's my final structure for arsenic tribromide. On this one, I already gave you the formula. It's O2. To start this one, we do the same thing. We say that each oxygen has 6 to start with, times 2, so you have 12 valence electrons. And when you just have 2 elements, they're just going to hook together. So that's your basic structure. Make sure you subtract how many lines we just drew and go ahead and finish drawing this one out. Restart when you're done. So you should have subtracted 2, giving you 10. This oxygen needs 6 more because it has only 2, and the other oxygen also needs 6 because it only has 2. So I need 12, but I have 10. So 12 minus 10 means I have 2 that I'm short. Divided by 2 means 1 more line. So if I add my other line, now each oxygen currently has 2, 4. So I just need to add 4 dots on each of them to get to 8. So it's 2, 4, 6, 8. And 2, 4, 6, 8. Again, I'm going to double check. 2, 4, 6, 8, 10, 12 is how many I started with. And I've used all 12. So this is the correct picture. Go ahead and pause the video and try this last one on your own. Restart when you're done. So hydrogen had 1, Br had 7, so you had 8 valence electrons to work with. Just like that last one, we're just going to hook them together. We subtract 2, so we have 6 left. But in this problem, hydrogen doesn't need any more because it currently has a line, which is 2 electrons. And then Br currently only has 2, so it needs 6 more. So I need 6, I have 6, so I can just add them as lone pairs. So that's my structure for HBr.